Alrighty. In this lesson here, we're going to be talking about 9.4, and that is our parametric equations. All right, there's not too much notes per se inside the lesson, just a lot of different examples. So I'm actually going to go straight into the review problems and stuff like that so that you can see all the different type of questions you'll see on your homework. For starters, we'll start with number one. So it says, given a parametric equation, x equals 5 plus t, and y equals the square root of t divided by t minus 2. It says construct a table of the given points that result from the integer t values, so the t values, from 0 to 6. And then sketch the curve of your graph. So basically what you're going to do is you're going to produce a table like this. It's going to be t, you're going to have x, and then you're going to have y. And it says 0 to 6, so you're going to find the values of 0, 1, 2, 3, 4, 5, 6. And all you're going to do is plug in t to each one of these equations. So 5 plus 0 is 5, 5 plus 1 is 6, 7, 8, 9, 10, 11. So literally taking the t, plugging it in. Same concept here. 0 squared is 0, divided by 0 minus 2, that would give me 0. Square root of 1 is 1. So I'll go ahead and put a 1 here. And then 1 minus 2 is negative 1, which will give me negative 1 as my outcome. Plug in 2. Do my best job here to separate this. So plug in 2. I get the square root of 2 divided by 0, which would be undefined. Plug in 3. You get the square root of 3. And then 3 minus 2 is 1, so you just get the square root of 3. Plug in 4, square root of 4 is 2, and 4 minus 2 is 2, so you get 1. Plug in 5, you get the square root of 5 over 3. Can't reduce that one. Plug in 6, get the square root of 6 over, what is that, 4? There you go. So that's all you do. And then on your homework, you'll just kind of plot those points as best you can. So 1, 2, 3, 4, 5, comma 0 is right here. And you're graphing the x and y. So this is the x and the y. Then plug in 6, negative 1. So you get something like this. And then 7, undefined. So there's nothing there. So I bet you could just put a vertical, pretend that's a straight line. Then 8. And then 8 would be at square root of 3, which is like 1 point something. So I'm going to round them out there. Then I get 9, 1. So that'd be about right here. Then I would get 10 square root of 5 over 3. But that's less than 1. And then I would get 11 square root of 6 over 4, which is even smaller than that. So I'd probably get something like this. And then something like this. And then I think they just have you plot the points and then you just connect them, and I think that's pretty much it. But that's about it. If you're unsure about these numbers here, you can just always plug it in the calculator. But I can kind of see the pattern that's going to happen here is that I'm just going to keep going down. So I knew square root of 9 is 3, so this had to be less than 1 in itself. So same concept with the square root of 3 had to be a little bit greater than 1. That's just using things I know. All right, so let's do another one to make sure you have good examples. So let's look at number 2. Again, this time I'm given x equals tangent theta over 2, and I'm given y equals cosine squared theta plus 3. And the theta values instead of t would be 0, pi sixth, pi thirds, pi halves, 2 pi thirds, and 5 pi sixths. Oh, and pi. Ran out of room. But using the points, then sketch the graph of the equation. So we're going to plot the points and then just assume it's infinitely in all directions. All right, so again, you produce your table. So there's theta, there's my x, there's my y. So again, that's 0, pi sixths, pi thirds, pi halves, 2 pi thirds, 5 pi sixths, and pi. All right, if I plug in 0 into tangent, so I need a little graph here as well. Go over here. So 0, this would be 1 comma 0. So it's y divided by x. So 0 divided by 1 is 0. So tangent of 0 is 0 divided by 2 is 0. Plug it in here. Cosine of 0 is actually 1. 1 squared is 1. 1 plus 3 is 4. Pi 6, I'll just locate it right here, would be the square root of 3 over 2 and 1/2. 1/2, keep, change, flip would be 1 over the square root of 3. Divide it by 2. So that gives you 1 over the 2 square roots of 3. How could they want you to be? Oh, they want you to rationalize that. Okay, so then you would, let me give us some more room here. So this would be 1 over 2 square roots of 3. So then you would rationalize it, square root of 3, square root of 3. So you get the square root of 3 over 2 times 3, which would be 6. Cosine of pi 6 is square root 3 over 2 squared would be 3/4. 3/4 plus 3. How do they want that answer? Are they mixed? Improper fractions. So, so 3/4 plus 3, that would be 12/4. Was that 15/4? Of course, you can type that in the calculator if you need be. Pi thirds would be 1/2 square root 3 over 2. So now that would keep, change, flip. This time it'll just be straight up square root of 3 over 2. So I can leave it like that. This one then would be 1/2 squared. So that's 1/4. 1/4 plus 3. That's 12/4 plus 1/4, which would be 13/4. Pi halves will be 0, 1. This time, though, it now becomes undefined at this point. Pi halves here, that would give me 0. 0 plus 3 is 3. 2 pi thirds, located right here, would now be negative 1/2, comma, square root 3 over 2. So then I'll just get negative square root of 3 over 2. Then that right there would be negative 1/2 squared would be positive 1/4, 3. So that would give me back to 13/4. 5 pi 6, which would be located right here, would be negative square root 3 over 2, comma, 1/2. Keep change flip, you get 1 over the square root of 3, so negative 1 over square root of 3. So then I know it's just going to be this, but with a negative. Plug it in there as well. This will give me 3/4, negative 3/4, but still 3/4 when squared. Or sorry, negative square root of 3 over 2, which will give me positive 3/4. 3/4 plus 3 gives me that 15/4 again. And then pi would just be negative 1 comma 0. So again, this would be 0 over 2, which is 0. This would be negative 1 squared, which is 1, which is 1 plus 3, which is 4. And then you just take those points, plot them, and you would get something like this. So that's 0 comma 1 2 3 4. Square root of 3 over 6 and 15/4. That's probably going to be, actually, I have no idea. I'm going to have to plug it in. So hold on. So square root of 3 Divided by 6 gives me 0.28. So I'm barely going to go into this. And then 15/4, that's like 3 3/4. So that's about right here. And then I had square root of 3/2, which gives me 0.8. So I'm a little bit closer. But now 13/4 is 3 1/4. So it's about right here now. And then it's undefined at 3. So here's my, pretend that went through at 3. And then I see on the flip side, I have the same answers, this negative, and then I'm back to 0/4. So you can kind of see, give or take, this is most likely the path it will take. All right. All right, the graphing will probably be the hardest part, but I think the math itself is just math in itself. Just plugging it in and simplifying it as you can. All right, let's look at the different set of questions you'll get. Let's look at number 7. We want to sketch the graphs of the following parametric equations by eliminating the parameters. I think they just want you to produce the equations on your homework. I don't think they have you sketching. So x equals t over 4 and y equals t squared. So it doesn't matter which one you choose. You just got to solve for t for one of these equations. So if I start with this one here, I'm just going to multiply both sides by 4. So I get 4x equals t. Then take that and plug it in. So then I get y equals 4x squared. So that gives me y equals 16x squared. If you are having to graph, do something like this, give or take some points. All right, but then that's it. That's really your answer right there. It's really what you need to be able to do. Let's look at number 9. Give you a different example. This one is x equals the square root of t plus 3, and then y equals t plus 3. Again, it doesn't matter which one you solve. I just naturally default to my x, but it doesn't matter. So I'm going to square both sides, get rid of that square root. So I get x squared equals t plus 3, and then I'm going to subtract 3 on both sides. So I get x squared minus 3 equals t. And then I back substitute that in. So I get y equals x squared minus 3 plus 3. So that would just give me y equals x squared. So then my graph would look like this. But you do have to watch out. In this example, t can be whatever number it wants to be. It's on top of a fraction, can be whatever numbers. You're squaring it, can be whatever numbers. Here, t is actually inside of a square root. So the issue with this guy is you have to only graph a portion of it. Anything past whatever number gives you 0 there. So if I plug in t plus 3, so let's backtrack a little bit. T plus 3 has to be greater than or equal to 0. So that means t has to be greater than or equal to -3. Well, if I plug in -3 into y, I get 3. And when I plug in here, I get 0. So 0, when you, again, doing this little chart here, t, x, y, plug in -3, you get 0 and 0. So that's as small as it can get. I can now go to -2, which will then give me 1, 1, but I don't have any negative numbers. So therefore, that is the only portion of the graph you can have. So in a normal sense, it would be in just x squared, but because t is limited, t can't be anything less than -3. I can only graph half of this equation here. So just watch out for that. Easy algebra. However, there are limitations on some of them. So just watch out for those. Let's look at another one. Let's look at number 12. This one is x equals 3 sine theta minus 1 and y equals cosine theta over 2. Now, on this one here, we have theta that you're looking for. It doesn't matter which one you solve for. I normally default to X, but looking at Y, I'm thinking there's less going on over here, so I'm actually going to solve for Y. But again, it won't matter. It depends on how hard you want the work to look. So I'm going to multiply both sides by Y, so now I get 2Y equals cosine theta. I'll then take the cosine inverse of 2Y, and now I have theta. So now you come back and you back substitute in. So now this will give me X equals 3 sine. Theta is now going to be considered cosine inverse of 2Y minus 1. All right, so when it's written like this, you have to produce those little triangles from the earlier units in chapter 8. We let this be theta. Remember, cosine is adjacent over hypotenuse. So that means this is 2y, and then the hypotenuse would be 1 because you can just put it over 1. So then if I do some a squared plus b squared, I would get a squared plus 2y squared equals 1 squared. So that's going to be a squared plus 4y squared equals 1. And then a would be 1 minus 4y squared, so I'll subtract it, and then the square root of that. So this gives you the square root of 1 minus 4y squared. So therefore, when you're then asked for 3 sine, sine of this is opposite over hypotenuse. So this now becomes 3 square root of 1 minus 4y squared minus 1. And I think they'll accept that as an answer. No. So they actually want you to solve for y from here. So maybe it would have been easier to go this direction. Regardless, this is where we're at. I'm just going to solve for y. So I'm going to add 1 now. So I get x plus 1 equals 3 square root of 1 minus 4y squared divided by 3. So I get x plus 1 divided by 3 equals square root of 1 minus 4y squared. And then I'm going to square both sides. So then I get x plus 1 over 3 squared equals 1 minus 4y squared. And then running out of room. So I'll then take this answer, x plus 1 over 3 squared minus 1, divide that by negative 4. So I subtracted the 1 and divided by negative 4. And then now I'm going to take the square root. So your final answer, plus or minus, would be plus or minus this guy right here. Equals y. And then actually, if you do graph each portion of that in your calculator, it does give you like a oval or something like that. All right, so maybe on that one, maybe we should have stuck with solving for x since it did want it in a y equals equation. However, we could, had it just asked for a parametric equation without the thetas, this would have been acceptable as an answer as well, because again, it has no thetas. All right, so those are some different looking problems. So let's look at a problem like number 34. 34 says it wants you to produce a parametric equation for the line of the given attributes. And we have a line that's passing through 6 comma negative 3 and 2 comma 3. So this starts off pretty basic. Just find the slope, get it into slope intercept form. So this is going to be again, so if you back when I used when I teach college algebra, we just label our stuff. So x1, y1, x2, y2, plug in the information, y2 minus y1 over x2 minus x1. Hopefully y'all know the slope formula at this point. But this will be 3 minus negative 3 and then 2 minus 6. So this will give you 6 over negative 4, which reduces down to negative 3 halves. And then to solve for the b, the part of the x-intercept, I'm going to plug into y equals mx plus b. So I'll plug in negative 3 equals negative 3 halves times 6. Again, replacing x and y with any coordinate. I just chose the first one, plus b. So now I get negative 3. 2 goes into 6 3 times. Negative 3 times 3 is negative 9 plus b. Then I'll add 9 to both sides. So then I get 6 equals b. Once I have my B and my M, my answer is y equals -3/2 x plus 6. This would be what you did in college algebra. Um, However, for a parametric equation, we need a t. So if you let x equal t, make it simple, then y would equal -3/2 t plus 6. Now you have a parametric equation where you have time affecting both x and y. And there you go. So start off easy and then just write the answer in a as easy as possible when it comes to t. All right, let's look at number 36. 36 says using the given values of x, construct a parametric equation describing the graph of each of the following. So we have y equals 3x plus 1, and you're told that x equals 2 plus t. So all you have to do is replace x with whatever it tells you to. So this becomes y equals 3 times 2 plus t plus 1. So if you distribute, you get 6 plus 3t plus 1. So overall, you get 3t plus 7. And that's all you have to do. So you're given this, you just got to go find the other equation. All right, let's do a few more of those. Let's look at number 38. So y equals 5 minus x squared, given x is equal to t plus 1. So again, I'm going to plug that in. So that gives me y equals 5 minus t plus 1 squared. Remember that t plus 1 squared is the same thing as t plus 1 times t plus 1, and then you fold that out. That gives you t squared, and that gives you t and another t, so that gives you 2t and then a 1. So this now becomes y equals 5 minus, notice I'm keeping the parentheses because I haven't applied this negative yet, t squared plus 2t plus 1. I will then distribute the negative, so then I get y equals 5 minus t squared minus 2t minus 1, and then write this from in standard form with the highest degree to lowest. So that'd be negative t squared minus 2t plus 4. There you go. And then given that, this is what your y would equal. All right, one more of those types. So let's look at number 40. This one says x squared over 2 plus 6 equals y, given x equals t t minus 4. So I'm going to plug that in. So that's going to give me t minus 4 squared divided by 2 plus 6 equals y. So remember this t minus 4. I don't know why I keep doing that. So t minus 4 squared, again, is t minus 4 times t minus 4. So again, I get t squared. T times -4 is -4t, and then another -4t gives me a -8t, and then a positive 16. So this will give me t squared minus 8t plus 16 divided by 2 plus 6. They might want you to simplify that. Let me check what your homework answer was for that. They did. So what they did is they then applied the 2 to all of this. So this becomes 1/2 of t squared. 8 divided by 2 is 4, so this is -4t. 16 divided by 2 is 8 plus 6 equals y. Combine like terms, so I get 1/2 t squared minus 4t plus 14. There's your equation for y. All right, let's look at some different types still. So let's look at number 42. 42 says construct a parametric equation for the circle with a given attribute. You're told that the center is 0, 0, and the radius is 1. So to write out these type of equations, you need to know how to write them out as parametric equations. So x is equal to h plus r cosine theta. Y is equal to k plus r sine theta. This is your h and k. So whatever center is given to you, this is your h and k, and of course your radius is r. So then you just plug it in. So h would equal 0 plus 1 cosine theta, and then y would equal 0 plus 1 sine theta. So this would basically just be x equals, oh, too many equal signs. It'd just be cosine theta, and then y would equal sine theta. So there's your parametric equations for a situation like that. Alrighty. So then it finishes up the homeworks with some word problems. So let's look at number 46. It says Francisco or Francos, we'll call the student F, shoots a basketball at an angle of 48 degrees. So we're given an angle, so theta equals 48 degrees. From the horizontal, it leaves his hands at 7 feet. So his initial height would be 7 feet from the ground with a velocity of 21 feet. So the velocity is 21 feet per second. All right. A says construct the parametric equations representing the path of the ball. So here you go. So A, construct parametric equations representing the path of the ball. So what you need to know here is how to find the X and the Y. All right, so to produce X, it is just going to be the initial velocity, this is initial, times cosine of theta times t. This would be the X value or X equation. This Y equation comes from, it's the very beginning of this lesson. It initially gives you a quadratic equation to find the arc of something. That's a generic equation where you just plug in the information. And then we were able to then to produce these equations. So -1/2 g represents gravity, e squared, plus v initial velocity sine theta times t plus initial height. So g here, gravity will be 32 feet, I believe is what it is. All right, so I think you have another one for meters or something like that, but that's what gravity would be because we are in feet. So then you just plug in the information. So this is going to be 21. Oh, that's a 12. 21 times cosine of 48 degrees times t, and then this would be y equals -1/2 of 32 times t squared plus 21 times sine of 48 times t plus 7. Of course, they want you to plug this in to get a roundabout, so let's quickly do that. So this would be 21 times cosine of 48. Again, on your calculator, make sure you're dealing with degrees again, and you get 14. Did it say what to round to? Let's see, your homework rounded their answers to 2 decimal places. So this will be 14.05 t. And there you go. Then do the same thing over here. This would be y equals half of 16, or 32 would be 16, so -16 t squared. I'm going to plug that in as well. 21 sine of 48 gives me 15.601. So 15.61, sorry, 06, the 6 of the 0 to become a 1. So 15.61 t plus 7. You've now produced your equation. You're then asked, well, I think on your homework, I think that's as far as you go. Actually, is it? You know what? Let's just do it anyways, as a case. Part B then says to sketch the graph of the basketball's flight. So in part B, you would basically just plug in 0 and then 1 and then 2 and then 3, so on and so on into the equation to produce the outcome, basically, for the X and the Y. Best approach to do that to have to produce a whole bunch of tables. Man, yeah. So I think on that one, hmm, on this graph portion, gonna be some type of arch. Let's see. Okay, so let's play around a little bit with the calculator. Hold on, let me switch over so you can see what I'm doing. Oh, this button. All right, so make sure you're all seeing it. Oh, perfect. Okay. All right, so curious. Let's look at graph. Let's plug in the y one, but we'll change the t's to x's. So that would have been negative 16 x squared plus 15.61 x plus 7. All right. And then you can actually do this menu 5 1. It turns on a trace. So menu 5 1. And then you can kind of trace around it. So obviously 0 7. But then this stops at 1. Let's see, how can we combine? So if we do tab, we can also type in our x equation, which was, well, actually, I won't be able to. This be solved for y. There's not a y that's going to produce. Well, let's pretend it's not. So 14.05x is something like this. I don't think that's going to help us any. Let's do it a different direction here. If I say, man, I just would hate for you to happen to plug in all of those numbers to produce an equation or a graph. Sorry, the equation you already have. Let's look back at some examples. That's what they did. They plugged in random numbers until they got an answer. All right, so that's what we can do. I'll show you real quick. If you just kind of like click on like you have that menu 5 1 on, so menu 5 1, there we go. You get the up and down button to switch between the equations. And let's say I wanted to produce a table, and let's say we started at 0. I can just type 0, hit enter, and it'll take me right there. So I can see the values of x and y. And then let's say I wanted to do 0.5 next. So I can see that my y would be 10.8, where my x would be 7. So I can kind of use that maybe to quickly get my answers. Might be a direction you could go as well to quickly get the answers. So with that said, I'm going to switch back to the whiteboard and use that idea to help us get somewhat of a graph. So here we go. So here is my graph. I know 1, 2, 3, 4, 5, 6, 7. I know there's a point there. And I got 0.5 for my t. So again, this is still going to be x and y. If I go at 0.5, I got 7.03 and 10.8. So 7.3. So 1, 2, 3, 4, 5, 6, 7, and 10.8. So that's going to be 8, 9, 10, 11. So again, I got, when I plug t in for 0.5, I got x equals, let's do it one more time, 7.03, comma, 10.8. So again, 7.3, roughly 10.8, looks like that. And then if I did t equals 1, Again, going back with that menu 5-1 on, I got 14.1 for my X. And then, oh, it won't let me switch. Oh, I got 6.61 for my Y. So at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 14.1, 0.61, roughly right there. Then if we do 1.5, get my X value at 1.5 would be 21.1. And negative 5.58. So the issue here is I can't go into the negatives. Um, so knowing exactly where this is going to hit. Yeah, so I have something that will produce this right here, basically. And if I want to know when it hits 0 on the x-axis, I would need to solve for t. So that would mean that x equals, sorry, if I let x equals 0, that would mean that 0 is equal to, how that's produced, that won't be right. Oh no, I would want to know when y equals 0, sorry. When y equals 0, that will tell me what my x could be. So when I plug in this, I could solve for 0 on that equation. And so when I do that with that menu trace on, I can just see where it crosses the x-axis there. And I see it actually happen. So in finding where y is 0, x would be 1.31. But that is actually my t according to this equation. So my t would equal 1.31. So the ball is going to only be in the air for 1.31 seconds. So there's a rough sketch. That's super hard to figure out, like trying to get some good points there. But then the next question, if the basket is 15 feet away and 11 feet high, will it make it? Well, it's only in the air for 1.31 seconds. So if it is 15 feet away, so that means x is 15. So when x is 15, 14.05 divided by t, get whatever that answer is. So let's quickly do that in a calculator. So that'd be 15 divided by 14.05. I get approximately t equals 1.06762. I'll be real specific here. Then you want to take that and plug it into the y to figure out, all right, what's the height? So then what I'll do with that graph, I'll make sure I'm on the y equation and I'll just type 1.06762 and it will take me straight to the answer. And it says then that y is equal to 5.43. So when it is 15 feet away, it's actually only 5.43 feet in the air. So that means if you're 15 feet away from the basket, you're not going to be 11, you're not going to hit 11 feet high. It's only going to be 5.43 feet in the air. So you would miss it. So part C there, if the basket's that, will it make the shot? No, it will not. So this is kind of using those equations, kind of manipulating it to your best ability. But let's do another one. Producing the equations, I feel like, are the easiest, but like trying to graph it, answer these questions, use the calculator. I think the graph and the menu 5-1 to produce those answers, so you're not having to retype it, plugging it in, retype it, plugging it in. It's probably going to be your easiest route. So let's look at number 47 as another example. It says, suppose that a circus performer is shot from a cannon at a rate of 80 miles an hour. So we have an initial velocity of 80 miles per hour at an angle of 60 degrees from the horizontal. The cannon sits on a platform 10 feet away. So our initial height is 10 feet above, sorry, 10 feet above the ground. And so part A, it wants us to construct it. The issue with this one is you have something that's in feet and you have something that's in miles. So we have to convert this into feet. And we'll just go ahead and convert this into seconds, mainly because if you look at question C, how high is the acrobat in 1.5 seconds? We're going to need the answer in seconds as well. So 80 miles per hour. We write this all out. This will give us, if we convert miles into feet, so 1 mile, there's actually 5,280 feet in 1 mile. And now let's work on our hours. There's 1 hour every 60 minutes. And then there is 1 minute every 60 seconds. So when we produce this, we just do 80 times this, divided by 3,600, because that's what 60 times 60 is. So I'm going to do control divide so I can do it all at once. I'll do 80 times 5,280 over 60 times 60, which gives you 350. Oh, that's a 2. 352 over 3 feet per second. Now we have a correct ratio of feet in second to compare with our feet and our answer or question that we'll have later. We can then go back to our x. So our x is going to be that initial velocity times cosine of theta times t. Y would be the negative 1/2 times gravity, t squared, plus the initial velocity of sine theta times t plus the initial height. And remember, we're going to let gravity be 32 feet. I think it's like per second or something like that. But we'll say 32 feet for now. So therefore, x would equal 352 over 3 times cosine of 60 t. And then I think they want you to write that out in decimal form, most likely they do. All right, so let me quickly do that. So I'm going to take that answer, times it by cosine of 60, and I roughly get 58.67 t. And this is y. This is negative 1/2 times 32 times t squared plus the initial velocity times sine theta t plus the initial height. So this will give me negative 16 t squared plus 352 over 3 sine 60 t plus 10. So I just now have to convert that last one. So negative 16 t squared and you get 101.614 t plus 10. So again, that part's the easy part. The next part, you have to sketch the flight, which I feel like is pretty gruesome. Again, I'm gonna start off with like t, x, y to give us a, oop, and I'll start with I said like 0, 0.5, 1, 1.5 and see how we go. So what I'll do again in my calculator, I'll go to graph and I'll just type both equations in. I'll start off with the y, so negative 16x squared plus 10.1. Oh, nope, 101.614 x plus 10. You'll get an answer there. Then I'll hit tab. I'll 58.67x. So both graphs are in. So if I then do menu 5.1 to trace, the first answer at 0 would be 10. My x at 0 would be 0. There's my first good point. Then we'll do 0.5 next. Actually, kind of looking at it, I bet we go 1, 2, 3, 4, 5, 6. I think there's 6 seconds looking at that graph initially. So I actually will go 1, 2, 3 to give me an idea what the graph would look like. So again, over here, I'll plug in 1 and I get 95.6. And at 1 here, ooh, I did not write that right. So hold on, let's check that. So tab it. I put a 0 instead of a decimal. Decimal. There we go. All right. So then menu 5.1. Let me get back to where I was. Go to 1. All right, that's better. 58.7. It's getting a ridiculous number there. 2. Again, I just chose these numbers. You can choose whatever. I think this will give you your best idea of where to go with this. Um, 2. So again, I want to go to 2. And for my X, I get 117. For my Y, I get 149. And then I'll go to 3. And that takes me to 171. And then I get 176. All right, so that gives me an idea. So here's my graph. Got 0, 10. It looks like as I go 1, 2, 3, 4, 5, 6. Again, about time I get to about 3, looks like it's probably going to come about down to about here and then something like that. Plug it in as close as you have to, but you'll have something that roughly looks like that. But I want to make sure I get to these other questions. How high is the Acrobat 1.5 seconds after leaving? If you're looking for the height, you just got to plug 1.5 into this calculator or into the Y equation. So I'm going to go back to my menu 5.1. I'm just going to type 1.5. And when T equals 1.5, Y actually gave me 126 feet. All right, so there you go, approximately. Part D then says how far from the cannon should a landing net be placed? So what you want to do is find out at what time for the former land. You actually want to do E first. So the time at which you land will be where it equals 0. So I'm going to go find out my x-intercepts for that equation. And it looks like it's at 6.45 seconds. Oh, that's a 5.4. 6.45 seconds. So that would be the answer to this one, 6.45 seconds. And then it says how far. Well, then you just take that and plug it into your x. So then I come back over here and I go 6.45 for the x, and it's 378 feet away. So my x here would be 378 feet, give or take. And then part F says if a 12-foot high wall of flames is placed 70 feet from the cannon, why will he clear it? So you want to go to 12 feet high. So I just need to figure out where 12 feet is on the Y. That's going to be kind of hard. Let's try 0.1, 0.05, 0.025. Okay, it roughly looks give or take, the time would be 0.025, give or take. So if I plug in 0.025 and I go to the X, 0.025. So if a 12-foot high wall of flames is placed 70, oh, but we got to go 70 feet away first. So again, this is going to be where I do, so in that F, I misread that one. So if I'm 70 feet away, I would say X is 70 at what time? 58.67 T. So then when I divide that, let's quickly do that so we can quickly get our answers. So 70 divided by 58.67 is 1.19. So then I'll come back over here and I'll go 1.19. And I would be 69.8. Oh, wait, no, I have to hit the X. I was on the X. So I'll be 108 feet in the air at that 1.19 seconds. So therefore, yes, I would clear 70 feet. All right, so then that's the rest of the other problems as well. That's about all the time I have for today. But if you need more examples, use the calculator to kind of help you with these type of word problems. The main gist is be able to get to here and here. If you can do that, the calculator will do the rest for you. But as always, if you ever need any more help, reach out and I'll definitely help you out. Until the next video.